folks, so I'm going to barrel into this problem because I don't have very long that I can record this. My computer says I have less than 20 minutes. So I know you've probably read this problem. If you haven't, pause me and read through the question. But what they're trying to do is get us to prove a formula, and that if we add one more element to a set, we're going to have twice as many subsets. They're trying to get us to prove that. And what I want to do is show you an example with a real set and see if we can come up with these answers just looking at that instead of proving it for every single size set. So they're telling us that the number in A, okay, so the number in set A is n. Remember, that's notation. Whenever you see an n in front of a set, that's telling you how many elements are in that set. And then you have the number of subsets is s, okay? And they want us to, well, they know the number in B is n plus 1 because B adds one more element. My pen's not doing right, I apologize. And they're trying to show that the number of subsets is s. So here's what we're going to do. We're going to just build a set A ourselves. Okay, I'm going to do this in a different color. Let's do it in green. So A is going to be the set that contains A, B, and C. Okay, now I want us to pause real quick and list all the subsets of set A. I'm going to do it fast. So first of all, the empty set and the set itself. So A, B, C. Those are subsets. Okay. What about each letter by itself? So A by itself, B by itself, and C by itself. Okay. And then we can combine A with B, A with C, and then don't leave out B with C. Now, is that all of our subsets? Well, we're supposed to have 8, right? 2 to the third. So let's count them. That's 1, 2, 3, 4, 5, 6, 7, 8. That's all of the subsets of A, B, C. Okay? Now, we're supposed to compare that. What if we add a set, let's do this in purple, that has one more element in it? Set B. And this time, it's going to be the set A, B, C, E. Because they wanted us to call the new element E. So let's list all the subsets for that one. So remember, we have the set itself, A, B, C, E. And then we have the empty set. Remember, those are always subsets, the full set and the empty set. Now let's just do one at a time. That's A, B, C, and E separately. A, B, C, I can get the bottom of the page, and E, okay? And then how about 2 at a time? So that would be A with B, okay? A with C, A with E, okay? And then we're going to look at B with C, trying to keep this very organized, B with E, and then finally I'm moving to the right one more, C with E. All right, and then 3 at a time. So that would be A, B, C. I'm going to go to the top of the page, A, B, C. Okay, A, B, E. Okay, and then how about B, C, E? Is that everybody? So A, B, C, A, B, E, B, C, E. Yeah, that's all of them. Now, if we used our formula, we have 4 elements, right? Which would give us 2 to the 4th, which is 16. Let's count, see if we have everybody. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm leaving somebody out. I see it. It's A, C, E. Okay, so A, C, E. Okay, that's everybody. Okay, now, in this problem, it wants us to look at 2 different things. Okay, it says, we now have the last line, we now have a new set B with n plus 1 elements. Divide the subsets of B, which we listed them all out, into those that do not contain E and those that do contain E. So y'all, I'm going to change colors to, let's just say pink, and I'm going to circle all the subsets that contain E, okay? So A, B, C, E contains E. The empty set doesn't. E certainly contains E. A by itself, B by itself, C by itself does not contain E. Neither does A, B, A, C, but right here, AE contains E. BC doesn't contain E, but BE has an E in it, and so does CE, okay? And then I know it's hard to read my writing because my pen's real squirrely, but this is ABC, that doesn't contain E. This is ABE, that does. BCE does, and ACE does. Okay, now look at the ones that I haven't circled versus the ones that I have circled. Okay, so don't look at the original set. That ABC doesn't count. Okay, it's listed here. I circled it here. So notice how many I circled. It's 1, 2, 3, 4, 5, 6, 7, 8. How many did I not circle? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so basically, look at the guys I didn't circle. They're exactly the same as the list I have over here to the left. So what they're trying to get you to realize is when you add one more element, then what you do is you take the subset list from previous and put an E with every one of those, which means it's going to double the number of elements. I know that still may make you feel really super confused, but I think with this example, it makes it clear. So my list in green is the same as my non-circled list over here in purple. And then my list circled in pink is just exactly the green list with E added to it, or exactly your non-circled purple list with E added to it. So how do I answer these questions? Let's see if we can get this done. And I want to answer this in a different color. What color do y'all want to use? Let's use orange. Got bright colors all over the place. Okay, so question A. How many subsets of B, so we're looking over here to the right, do not contain E? Okay, now in our particular problem, that's 8. There are 8 subsets that do not contain E. But 8 is also the number of subsets that we have in our original graph. Our original set, and so the answer to that is S. So the answer to question A is there are S subsets that do not contain E. Now it's 8 in our problem, but it's S for what they're asking. How many subsets of B do not contain E? Do contain E? Okay, well, there are 8, just like there were 8 that were not circled, so that is S for our problem. So the answer to question A is S. The answer to question B is S. So what is the total number of subsets of B? Well, it's 16, right? Which is 2 times 8. For our question, that's going to be 2 times S. And when you type it in, they'll have a little mark where they want you to put times, and then you put 2, because the S is already there for you. So it's S times 2, which gives us the answer 2S. What do you conclude? Okay, well, it's a really strange line that says the empty set contains n equals 0 elements. Okay, so the empty set, again, is n equals 0 elements. You will type in 0. And has exactly 1 equals 2 to the 0 elements, okay, or subsets. Since the previous step showed how the number of subsets increases with each increase by 1 in the value of n, the general formula for any value of n must be 2 to the n subsets. Okay, now again, don't get hung up in the formula. I want you to kind of just look at this example I did and notice the big point. The big point is if you have, for instance, 3 elements to start with and you list all the subsets, that happens to give you 8. If you suddenly change it to 4 elements, all of your subsets match the previous subset list, plus all of those also have your new element in there, which gives you twice as many subsets, and that does give you the formula 2 to the n plus 1. Okay, when you add an element, it's 2 to the 1 more up here. Okay, which gives you twice as many as previous. All right, if you have any more questions about that, let me know. Don't worry, I don't put anything like this on a test, okay? But it's a really neat problem to think through. Hope you have a wonderful day and send me any of your questions.